Okay, so today I'm going to be talking about Kruskal's algorithm. Kruskal's is a greedy algorithm that finds a minimum spanning tree for a connected graph. And it makes a minimum spanning tree so it doesn't have any cycles. But unlike prims, with Kruskal's, we are free to take any edge that we want, regardless of if it connects to any edge or node that we've already used. So here's the example we're going to be working through. And we're going to suppose that we're going to just take whatever is the minimum edge to start with. So we're not starting with any particular node or edge, we're just going to find the minimum. And when I work through a Kruskal's problem, I like to make this sort of table. And what this table is you're going to have a column for every edge in the graph and you're going to order it from least to greatest. So here's my table. It does have every edge in the graph, and as you can see, it goes from least to greatest, left to right. And we're going to go through every column and see, can we take that edge, and is it valid? Does it make a cycle? And so we'll see as we go through the example. We'll start with the first one, because this is the minimum. And we're going to say, okay, so edge BC is right here. We're going to take that. So I'm going to mark that off on the table. And on the graph itself, I'm going to mark the edge. And I'll mark the nodes to say that those have been visited. So then we'll move on to the next edge, which is EF. And as we can see here, if we take EF, we're free to do that. That does not make any cycles with the BC edge. So I'll do the same thing. I'll take this edge, and I will mark those nodes as visited, and I will mark it on the table. And so the next one we have is AB. So we go to AB, and still we're free to take this one. It does not make any cycles, and I'll mark that one. Mark it on the table. And now we move to BF. BF we are still free to take. There we go. CF. We are not good to take CF. And the reason is because if we take this one, CF, then this creates a cycle in this little triangle here. We do not want the path to sort of connect upon itself. So we are actually not going to take CF, and instead we're going to move on to the next one, which is AF. And if we look at AF, we can see we have the same problem. If we connect these, we have another cycle here. So we actually cannot take that one either. So we move on to DF. And if we look at DF here, we are free to take this because it creates no cycle. And once we go and we take DF, we don't really need to consider any other edges because, as we can see, AE is going to make a cycle, CD is going to make a cycle, and DE is going to make a cycle. We have visited every node, and our path does span the whole graph, and so these are the edges we would take to find the minimum spanning tree using Kruskal.